diabetes and gold nanoparticles. Now let us get to know about what type 1 diabetes is, some of the complications that arise due to type 1 diabetes, and what are some of the methods that are currently being used for type 1 diabetes management.
When you have type 1 diabetes, your body attacks the insulin-producing cells in your pancreas, so you can't produce any insulin at all. And we all need insulin to live. It does an essential job. It allows the glucose in our blood to enter our cells and fuel our bodies. When you have type 1 diabetes, your body still breaks down the carbohydrate from food and drink and turns it into glucose. But when the glucose enters your bloodstream, there's no insulin to allow it into your body's cells. More and more glucose then builds up in your bloodstream. High glucose levels in your blood can seriously damage your heart, your eyes, your feet, and your kidneys. These are known as the complications of diabetes. You get insulin into your body by injecting it, or using a pump which delivers a constant supply into you. You'll also need to check that your blood glucose levels are not too low or too high by using a blood glucose testing device several times a day.
That was more of a theoretical knowledge, but what about real life? Let us get to know about type 1 diabetes
Last
from
June,
Sam.
I have been diabetic since the age of 11 and I'm insulin dependent. I currently take injections 5 times a day.
You heard it correct, 5 times a day. Now you might be wondering about other problems that type 1 diabetic patients suffer from. Let us get to hear from Sam himself.
My daily routine is a bit different to someone without diabetes. I have to wake up, do a blood test, have some insulin for my food, then repeat the process of injecting and blood testing at lunch and dinner, and then I also have to inject before I go to bed. Depending on how busy my day is or what I'm doing, sometimes I don't do all the blood tests I'm supposed to. Very occasionally I don't do all the insulin I'm supposed to.
To overcome such problems, we have come up with a solution, which is essentially divided into 2 parts. First is the early prediction of diabetes, and second is the utilization of nanotechnology and gold nanoparticles to treat diabetes. Before moving on to the solution part, let us know what nanotechnology is.
How small is the smallest piece of technology you can imagine? The size of a grain of rice? A grain of sand? How about the width of an individual strand of spider's web? A red blood cell? Narrower than a single wavelength of visible light? Okay, now we're talking. Welcome to the realm of nanotechnology. At this minuscule scale, we measure things in nanometers. To give you a rough idea of just how small those are, in one day, your fingernails will grow by around 86,000 nanometers, about the width of a human hair. By comparison, nanotechnology is defined as being between 1 and 100 nanometers across, which is just a touch more than your fingernails will have grown since you started watching this video.
In part 1, we have selected several major risk factors and variables, and with the help of machine learning, we have developed models through which we have predicted diabetes at an earlier stage. In the part 2 of the solution stage, we basically utilize gold nanoparticles for measuring glucose levels and also for the administration of insulin into the body. These solutions mainly aim at minimizing the diabetes complications. The engineering problem is divided into 3 parts, that is, theory, manufacturing, and economical impacts. First one being the theory includes components like ML model, gold nanoclusters, and theories revolving around toxicity and fluorescence of particles. Second being the manufacturing stage, which essentially includes the manufacturing process of gold nanoparticles, and the third one being the complexity of the treatment. For early prediction of diabetes, we basically made use of 3 algorithms and then we compared their accuracies. First one being the decision tree. It is a model in which the data points are classified on a certain parameter. This is the decision tree predicted model. We also made confusion matrix to better understand the algorithm. Next was the random forest. It is based on various subsets of a given dataset and it takes average to give precise values. F1 scores were also calculated. Last one was the name-based theorem. This classification technique is based on the famous Bayes theorem principle. The accuracy values of all the models were compared and random forest was found out to be the most efficient and accurate model for early prediction of diabetes. Now let us get to know some of the interesting facts about gold.
Half of the gold that comes out of the ground is used to make jewelry. Another big chunk is used to make gold bars and coins. We've been using gold in this way for thousands of years. But recently, researchers have been experimenting with using tiny amounts of gold in technology and taking gold medicines. Gold makes good watches, rings, and coins because it's inert. It doesn't really react with oxygen, so it stays looking nice and shiny. It's actually a pretty boring metal from a chemistry point of view. But zoom into the nanoscale and gold gets more interesting. This gold nanoparticle is the size of a virus. At this scale, it's easy to manipulate and harness the surface properties of gold. For example, Molecules like drugs can be attached to the surface of the gold, can then carry these drugs to where they're needed in the body. Inert gold is a good delivery vehicle because it doesn't react with other molecules in the body.
Gold nanoparticles can prove out to be a good delivery agent of insulin. These are some of the chemical reactions that give rise to the gold nanoclusters. The final product obtained is very sensitive to glucose levels and therefore effectively maintains the blood glucose levels by releasing insulin as per the body requirements and overall helps maintain normoglycemia.